Dear students, welcome to the first lecture of the course Solar Energy Engineering and Technology. So, today we will be discussing about energy scenario. So, before we start the exact energy scenario, let us discuss some of the important terminologies associated with this course. So, what is energy? This energy defines as the ability to do work, the capability to do work depends on the amount of energy one can control and utilize. The work output depends on the work input. The energy is the most basic infrastructure input for economic growth and development of a country. Now, what is the unit of energy? The international system of units of energy is joule. Then what is power? Power is nothing but the rate at which energy is transferred or transformed. Now, what is the unit of power? It is watt, right? Now, what is the commercial unit of energy? It is kilowatt hour, right? Let us learn in deeper sense what is kilowatt hour. So, normally we know unit, okay? What does it mean? So, 1 unit is 1 kilowatt hour, okay? The electricity used is generally charged in unit of electricity. The kilowatt hour is the product of watt and time. That means 1 kilowatt is equal to 1000 watt, okay? And if we multiply with time, it becomes watt into time. That may be in hour, minute or second, okay? Normally, if we have to define unit generation, then we need to multiply watt with hour. For example, 2 kilowatt capacity or rated heater switch on for 3 hours. What is the consumption of electricity? So, straight away you can calculate it. So, 2 kilowatt is the rated power multiplied by 3 hours, it will be 6 kilowatt hour. So, this will be in hour, okay. So, if we know 1 unit cost means 1 kilowatt hour is equal to say rupees 6, okay. Then amount of money required will be how much? So, it will be 6 multiplied by 6, which will be equal to rupees 36, okay. So, this rupees 36 we have to spend if we have to run the heater for 3 hours in a day. So, this will be 36 rupees per day. If we take one more example, say 50 watt rated ceiling fan operates for 5 hours per day, then what will be the electricity consumption? So, straight away you can calculate 50 watt, okay, multiplied by 5 hours, it will be 250 watt hour, okay. So, if we have to convert to kilowatt, then it will be 0.25 kilowatt hour, okay. And then if we multiply it with 6, then what will happen? So, money spent will be 0.25 multiplied by 6, which will be in rupees, okay. So, that will be in per day. So, that much of money will be spent if we operate this ceiling fan for 5 hours, right. So, that way you can calculate the amount of energy requirement to run a particular electrical utility. Now, why this energy is required? Of course, to meet energy demand in different sectors. It may be domestic, it may be transportation, may be agricultural or may be industry. So, if we talk about domestic, so it may be for offices, maybe individual households and other commercial buildings. Okay? So, this sector requires different energy at different forms. Okay? So, let us learn different forms of energy which is commonly used. So, what are the common forms of energy? Let us first consider thermal energy. Okay? This thermal energy is used to meet to various industrial and domestic requirements. Thermal energy can convert to mechanical energy by using heat engine. Okay? And this thermal energy can be categorized into 3 primary groups based on the temperature ranges. So, first category is high temperature if the operating temperature varies from 500 to 1000 degrees C or above, and second category is medium temperature operation if the temperature varies from 150 to 500 degree Celsius, and third category is for low temperature. So, if the temperature is varies from 80 to about 150 degree Celsius. Okay? For high temperature applications, this thermal energy can be converted efficiently into mechanical energy. For medium temperature applications, thermal energy can be converted to mechanical energy with certain difficulty. But in the last case, for low temperature applications, this thermal energy cannot be converted efficiently into mechanical energy. So, it is mostly used for heating applications. Now, let us discuss the second category of energy which is commonly used is chemical energy. So, fuels and organic matter contains chemical energy, and exothermic chemical reactions release heat energy, and sometimes we can convert directly electricity from chemical energy by using fuel cells. There are different kinds of fuel cells which can convert chemical energy to electrical energy directly. Maybe PEM fuel cell, proton exchange membrane fuel cell, maybe solid oxide fuel cell. There are many kinds of fuel cells which operate at different temperatures. Also, we can convert chemical energy to thermal energy by using combustion route. And about mechanical energy, this mechanical energy is required for movement of objects, changing the shape of the objects, and used in transportation, agriculture, handling, processing, and different other activities. Now, let us discuss about the electrical energy, which is the high grade energy, and more than 40% energy distribution in the world is made through electrical supply systems. And this electrical energy is very conveniently and efficiently converted to other forms of energy. So, this slide shows the development, how industrial development takes place, and how and when electricity was developed, and after that what happens. So, as you are familiar with this famous philosopher, so he is Aristotle. He is the first man to describe the concept of energy. So, he has given a statement. So, statement goes something like, it is clear that there is some difference between the ends. Some ends are energia, means energy, while others are products which are additional to the energia. The energy has always been among the most essential resources that endorse the progress, evolution, and prosperity of human societies. Energy use by human beings from the discovery of fire and the agricultural revolution to the industrial revolution and the dominance of fossil fuels. So, this man is busy with generating fire. So, that indicates discovery of fire by primitive man. So, this picture is very famous picture. So, he is James Watt. He invented the steam engine in the year 1785. The invention of steam engine brought the industrial revolution. After that, many more mechanical devices were developed, including internal combustion engines. So, this era from 1785 to 1888, the time when Tesla discovered induction motor. So, this era is known as mechanical era. Lot of mechanical machines or which develops or which generates mechanical energy was developed. In the year 1888, Nikola Tesla developed the induction motor. The invention of induction motor leads to commercialization of electricity. So, from 1888 that electrical era was evolved. Okay? So, many more technologies were developed. So, without electricity now we cannot think of our life. Okay? So, Tesla changed the entire scenario of the world. Okay? So, now this increases the energy requirement by leaps and bounds. Okay? After that many more technologies were developed. Now, let us pay attention about the progress of energy used, that is world scenario. So, this figure shows the energy use versus years. So, it was started in the year 1900 to 2009. So, this comparison has been reported in this figure. As you can see, energy requirement was very low when we compare 1900, and if we see in 2009, you can see the rise in requirement of energy. Okay? It is about 10 times more. So, this unit is exajoule. So, 1 exajoule is equal to 10 to the power of 18 joule. Okay? So, now see here the share of energy comes from different sources. So, this color is indicates biofuel, and then it's a coal. Okay? Coal and biofuel starting from 1900 all were present, but the share is increases with time. Okay? But this year is also very important. These years after World War II, many more things happens and people were given lot of attention to harvest energy from other sources. Again, if we see in 1970s, this natural gas uses increases after 1970s. So, this is natural gas. Okay? And oil consumption takes the lion's shares from 1960s, because all the machineries were developed by that time, and that is why it was oil who takes the lion's shares. And use of natural gas increases from World War II, and hydronuclear and geothermal electricity increases constantly from 1970s. Okay? As you can see here, these are increases constantly, and biofuel consumption increases throughout 1900 to 2000, okay? And further increase from 2000 to 2009, right? And this figure shows the world's per capita total primary energy supply from 1900 to 2009. As you can see here, this is almost flat curve, and then after World War II, there is a rise in total primary energy supply, and then it is continuously increases till 1980s. Then 1980s to 2000, again it is almost constant, some fluctuations were there, and then after 2000 again there is rise in total primary energy supply. Okay? That means what? Once primary energy supply is increases, means quality of life is increases, right? So, that way you can see, if we have to increase the quality of life, then we need to burn more fuels, and if we burn more fuels, then it will emit lot of greenhouse gas emissions. Okay? So, that we should keep in mind. Now, let us pay attention about the world energy scenario. So, this is the world map, and this world energy consumption is about 13.5 billion tons of oil equivalent in the year 2018. The energy consumption of China is about 3,164 million ton of oil equivalent in the year 2018, followed by US and India about 2258 and 929 million ton of oil equivalent respectively. China's energy consumption growth rate is 3.7%, and this growth was the strongest since 2010 and almost double the 10 years average of 1.5% per year. Now, let us see this figure. This figure shows the comparison of energy mix from 1970s to predicted 2040. So, as you can see, this share is increasing, right. So, this green color is oil, okay. Then this part is red is gas, then this gray is coal, then nuclear is this yellow, then blue part is hydro and renewable. As you can see, renewable was nowhere in 70s and 80s, very nominal, and as you can see in 2010 you can see some kind of visibility, and it is predicted that this renewable energy will take a rider seat in the coming years. So, as you can see here, about 80% of the share is coming from the fossil fuels, and as you can see about 158% increase in fossil consumption since 1970s to 2020, right. It is a huge increase in fossil fuel consumption. So, this slide shows about energy production versus years. So, as you can see, with years energy consumption is increasing. So, what we can conclude from here, in 2017 the world energy production is reported to be about 15,000 million ton of oil equivalent. So, it is equal to 575 quad BTU, which is nothing but this is equal to 1 quad BTU is equal to 10 to the power of 18 or 1 exajoule or 10 to the power of 18 joule. Okay. So, this is joule and equal to 1 exajoule. The USA and China were the main contributors, together contributing 54% of growth in 2018. Okay. India's share about 588 million ton of oil equivalent of global energy production, right. So, this slide shows about the world energy scenario at 3 different years. So, one is at 1978, one is at 1998 and other one is at 2018. Okay. So, in horizontal axis it shows energy per capita in gigajoule per head, and in the vertical axis it shows the population, okay, in percentage. These are percentage. Okay. So, in 2018 about 81% of global population consumed less than 100 gigajoule per head, and rest 20% consumes it from 100 to 350 gigajoule per head. Okay. You can see the non-uniformity of utilization of energy. The average energy demand per capita in China increased from 17 gigajoule per head in 1978 to 97 gigajoule per head in 2018. This is a huge rise in per capita energy consumption, right. Now, let us learn about effect of fossil based fuels. Okay? So, this figure shows the carbon dioxide present in the earth atmosphere. You can see the red colored. Okay? So, as per IEA report, the global carbon dioxide emission is estimated to be 32.6 gigatonnes in the year 2017. And if you see this figure and this figure is enlarged view of this figure, okay, which shows global monthly mean carbon dioxide. So, if we see very precisely this figure, this vertical axis shows parts per million of carbon dioxide, and here is the year from 1980s to 2020. So, you can see the variation of carbon dioxide in the earth atmosphere. It was 340 in the year 1980s, and it is keep on increasing, and now it is about 410, okay, close to 410. Okay. So, as we understand that permissible limit of carbon dioxide in the earth atmosphere is 350. So, you can imagine we are in the very dangerous situation now. So, we are really in a very dangerous situation, because this earth atmosphere contains more than 410 ppm, okay, carbon dioxide, right. So, this can be magnified view of this. It will be starting from 2015 and 2020. You can see how it varies, and now we are here. So, for comparison, so in December 2019 it was 412.02 ppm, and in December 2018 it was 408.94 ppm. You can see the rise in a single year. So, what are the adverse effect of this? There is a climate change. So, you can see the melting of glaciers and then drought in many part of the globe. Okay? So, we need some kind of alternative solution to mitigate those environmental problems. Okay? So, let us see the production of fossil fuel with years. So, this cumulative production, this BBLS is something called billions barrel per year. Okay. So, cumulative production till 1950s was 19 into 10 to the power of 9 BBLS, and proven reserve is about 250 into 10 to the power of 9 BBLS. So, with the existing technological intervention, we can predict the kind of reserve we have, but this part we do not have that kind of technological solution to estimate the amount of reserve we have. Okay? So, that is why future discoveries are required. So, it is estimated to be about 910 into 10 to the power of 9 BBLS. Okay? So, in the year 2000, the world's oil production reaches its peak value of 12.5 billion barrels per year. Okay? As of 2016, the world's oil production was 29.4 billion barrels per year. So, these fossil fuel reserves are rapidly depleting, that we really need to understand. So, why do you need renewable energy? Because of this climate change, we need to do something about this climate change issues, and we know very clearly about the energy crisis. In 1973, these OPEC countries, they stopped providing oil to the other countries. They increased the oil price to a very high value. So, it was very difficult to afford the countries not producing oil. Okay? Then people were thought about some kind of alternative solution, what to do, from where we can generate energy. So, this year is very, very important for the development of renewable energy technologies. Again in 1973, there was a crisis, and people were really forced to think about new development and generation of energy from alternative resources. And again 2018, there was a financial crisis. So, this altogether crisis actually forced researchers to think about some kind of alternative solutions. And of course, we need energy security and sustainability. So, what are the alternative sources we have? We have many like solar energy, wind energy, geothermal energy, hydro energy, bioenergy and tidal energy. Okay? Now, let us see this figure how the share of all the energy sources varying with time. So, from 1970s to 2040, from 2020 to 2040 is a prediction and these are the actual values. So, as you can see, this oil production is decreasing with years, and if we see coal is sometimes decreasing, increasing and then recent trend is to decrease, and it is predicted that coal utilization will decrease with coming years. And gas, of course, no, it will increase, and hydroelectric, it is almost constant and it is predicted that this will slowly grow, and nuclear is almost constant now and it will remain as per the predicted models. But as you can see, this renewable energy, it will grow and it will be in the driver's seats, okay, looking into the environmental problems and sustainability. So, share of renewable energy is growing at a rate of 7.1% per annum. The predicted to increase up to 15% by 2040 from 4% today. So, here what is shown here, like estimated renewable share of total final energy consumption in the year 2017. So, as you understand, about 80% of energy is coming from the fossil fuels and rest is from other sources, maybe nuclear, maybe traditional biomass, maybe other sources like hydropower, biomass, solar, wind, etc. This figure shows the annual addition of renewable energy capacity by technology, okay, from 2012 to 2018. So, as you can see, this yellow color is for PV, then this blue color is for wind, and this green color is for hydropower, and this orange color is for biopower, okay, and CSP. So, with years you can see the contribution of all the different sources of renewable energy, and as you can see here in 2018 this contribution of solar is extremely higher compared to other sources, and this axis, this secondary axis shows the cumulative of all, okay. So, it is found that it is about 181 gigawatts, okay, in 2018, that much of energy is produced from renewable sources, okay. So, what we can see here, this global energy power capacity total is about 2378 gigawatt in 2018, okay. This renewable energy targets had been adopted in 169 countries at the national or state provincial level by the end of 2018. More than 230 cities worldwide have adopted targets for 100% renewable energy in at least one sectors by end of 2018, okay. So, this kind of agreement has already been done globally. Now, let us pay attention about energy scenario in India. So, as you can see, share of renewable energy and other sources in this pie diagram. So, share of renewable energy is about 23.4%, nuclear is 1.9%, hydro is 12.4%, diesel is about 0.1%, lignite coal contribution is about 1.7, gas is 6.9, and major contribution is coal, which is about 54.2%, right. So, this 54.2% is equivalent to about 200 gigawatt of energy, and gas contribution is about 25 gigawatt, then lignite coal is about 6 gigawatt, then diesel is about 0.5 gigawatt, nuclear is about 6.7 gigawatt, then large hydro, which is not renewable, its contribution is about 12.4 and it's equivalent to about 45.3 gigawatt of energy received from this large hydro power plant. And as far as renewable energy is concerned, so we get energy from small hydro, wind power, solar power and biomass power. So, from small hydro it is about 4.6 gigawatt, from wind about 37 gigawatt, solar about 34 gigawatt and biomass is about 10 gigawatt. Okay. Now, let us analyze sector wise. So, we have three sectors: central sector, state sector and private sector. So, you can see the installation capacity. So, central sector install about 25.3% and state sector install about 28.5% and private sector is about 46.6. So, if we equalize in terms of gigawatt, so central sector contribution is about 93 gigawatt, state sector is about 104 gigawatt and private sector is about 171 gigawatt. And this thermal contribution increased by about 3.57 in this year and about 137% increase in renewable installation capacity from 2013-14 to 2018-19. It is a huge increase in installation of renewable energy. An overall growth rate recorded by 6.46%. Okay, that means people are using more energy. Okay, that way also you can think about quality of people in a particular country. So, why then solar energy? We have learned different alternatives. Then why so special about solar energy? So, we must know about that. First thing, it is a clean energy, and this solar power creates zero emission, okay, during its operation, and its availability. So, solar energy is available throughout the globe and it is affordable now and cost advantage. Okay. Since it is affordable, then people can take solar plant in their home to generate energy for their utility as well as to sell the electricity what they have generated in their household. And of course, no government support is required for installation of plants and get subsidies. Okay. So, what are the key benefits of utilizing solar energy? Save money on energy cost, a return on investment, reduces overall household carbon emission, increase value of property. So, it increases the value of the property, little or no maintenance is required for this kind of installation, the system is noiseless. Okay. These are the key benefits of utilizing solar energy. And other advantages are, as you can see, this cost. So, if you compare in the year 1977, cost was about $76 per watt. Now, you see it is about $0.3 per watt. That means, in the recent times in India, if government supports, we get a value about 2.5 rupees per unit cost, or if subsidies are not there, then maybe it will go up to 6.5 rupees per unit cost. Also, we need to understand this Swanson's law. So, this was developed by Richard Swanson, one of the owner of the solar company. So that's how it is known as Swanson's law. What it tells is the observation that the price of solar photovoltaic modules tends to drop by 20% for every doubling of cumulative shipped volume. At present rate, cost decline by 75% about every 10 years. Okay? So, this horizontal axis tells about the cumulative module shipments, which will be in megawatt peak, and in vertical axis shows average module price. You can see how it is decreasing with cumulative module shipment. Okay? This law can also be applied to understand the futuristic reduction of cost. Now, let us pay attention about installed solar energy capacity in 2018. So, as you can see, these dark colors are for China. So, this is China. So, they have installed huge amount of solar gadgets. Okay? So, they can generate more than 80 gigawatt of energy, followed by US and some of the European countries. And if we talk about India, it is more than 40 gigawatt, okay, in this range. And you can say, you can use this scale and we can understand the installations of solar energy across the globe. Now, let us concentrate about the solar energy scenario in India. So, this is a India map and you can see the scale here, okay, based on the color code. So, darker the color is the higher the solar insolation. Okay. So, we can understand the kind of energy available here. Maybe darkest section is 7.5 kilowatt hour per meter square per day. These regions are darkest, and then we get a higher solar concentration here. The solar installed capacity in India as on 28th February 2018 is about 19.6 gigawatt, and estimated solar potential in India is about 789 gigawatt peak. Okay. So, this chart shows about solar capacity, okay, of different states of India. 10 states are shown here. They are the major solar capacities. Karnataka, followed by Telangana, then Rajasthan, Andhra Pradesh, Tamil Nadu, Gujarat, Madhya Pradesh, then Maharashtra, Uttar Pradesh and Punjab. You can see the kind of solar capacity they have. So, once we know this color code of a particular region, we know the amount of solar radiation falling on that particular region. Okay. So, that way also we can think, and also we must know the solar hours. So, that way we can understand how many hours solar normally present in a particular locations, and we can estimate the amount of radiation available for conversion. And we can see this solar energy generation in 2018. So, here total solar energy generation, which is measured in terawatt hour, is shown here. So, China is producing about 177.5 terawatt hour, followed by United States, it is about 100 terawatt hour, followed by Japan, then 72 terawatt hour, then Germany, then India is about 31 terawatt hour. So, this figure shows the total solar energy generation by countries. Okay. So, we can summarize to what we have discussed today. We have primarily discussed about the definition of energy, the need of energy, and what are different forms of energy and where these different forms can be applied. And also we have discussed about world's energy scenario, then Indian energy scenario, then global trend of generation of renewable power, and finally we have discussed about trends of generation of solar power. So, I hope you have enjoyed this lecture. Thank you for watching this video.